the presentation of our last speaker for this afternoon. We are having Dr. F Rivera-Milan, who is a research wildlife biologist of the U.S. Fish and Wildlife Service, Patuxent Wildlife Research Center. He is a master of quantitative analysis who has evaluated population responses of numerous species to hurricanes throughout the Caribbean. Dr. F Rivera-Milan will present the topic maximum population growth rates, stability, and resiliency of endemic birds to hurricanes on Caribbean islands. Thank you, Dr. F Rivera.
Can you hear me?
Yes.
All right, great. So basically, hello everybody, and I hope everybody's healthy. I will be talking about long-term monitoring that we have been doing in different islands, including the Bahamas, Cayman Islands, Puerto Rico, where I've been working since 1986. A lot of what I will be saying is related to count data. So basically, these are point counts. So basically, with that kind of data, we'll be talking about maximum population growth rates of these different birds. And then I will touch on the subject of stability and resiliency. The three examples that I will use is a parrot, the Bahama parrot on the island of Great Inagua. Basically, a slow reproduction with high survival, a frugivore. I will be contrasting that with elfinwood warbler in the El Yunque National Forest. This is the population of El Yunque, which again is fast reproduction, low survival, and insectivore. And then I will also talk about the Puerto Rico plain pigeon, which kind of have more plastic, if you will, more plastic life history characteristics. Has a clutch size of 1 egg versus a typical clutch size of 2 eggs of pigeons, but basically it's multiple brooded. So it can combine slow and fast reproduction and medium to low survival, and it's a frugivore. Just to show that where Great Inagua is located, it's the southernmost island of the the Bahamas. It's, the island is about 155,000 hectares. We have points all over the island, so we're talking here hundreds of points. And Puerto Rico, where we have been working since 1986, we have over 1,200 points all over the island. I'm also doing work in different places, as you can see from the blue arrows, but I will not be talking about those today. But in general, I have something like 26 species that I can do similar analysis. Caribbean hurricanes, as we know, major class 3 to 5 are increasing in frequency and duration, and we're here winds of 110 miles plus. Again, direct and indirect effects, basically the wind and the rain and all that basically creates a problem, damage the vegetation, declines of food, and then we have the indirect effects after the hurricane, basically in terms of survival and reproduction, which leads then to population declines, abundance declines, which in the case of the 3 species that I'm talking about, again, because they are island endemics, they are geographically and isolated small populations. So they're risk of increase basically very much, or local extirpation in the case of the El Yunque population of elfinwood warbler. Basically, Hurricane Dorian is one typical hurricane in which you have a long duration, a hurricane that lasts like 14 days in the ocean, and it hit directly the island of Great Abaco. I will not be talking about that due to COVID-19. We're still pending on evaluation of that population, but we expect a very severe decline of the parrot population there. Anyway, just to show, this is Great Inagua after Hurricane Ike in 2008, and you can see how parrots are on the ground very much looking for food, in this case, almond tree. You can see this fruit basically lasts, they don't last long on the grounds. Basically, after a couple of weeks, the animals are really dying of starvation. So the 3 main objectives that I have right now very much are to estimate abundance and rate of change in abundance, accounting for changes in detection probability. And there are 2 components here, detectability and availability, which we're accounting for. And the second one is very much with a Bayesian state space model. We're going to be fitting this model to generate posterior distributions for population maximum growth rate and carrying capacity. We're all going to also make survey-based and model-based predictions between 2020 and 2030, accounting for process and observation variance. And then we will jump into an assessment of stability and resiliency. I will not be talking about the method very much, but very much in general, distance sampling with repeated counts is what we have used. In some cases, we have used playback, and in others not. And then basically a lot of this information you can find in this publication in Condor 2016. As I was saying, we're estimating density and population size, as you can see there, accounting for the component of detection that is related to the detectability of the animal at certain distance. And then we're also accounting for the availability of that of animals through repeated counts. With the Bayesian state space model, very much the only thing I will say is that we are now studying the true unknown population state or latent variable, very much using the data that we have for 15, 20, 30 years in different places. And now we're able to estimate rmax, or population maximum rate of increase. So population stability, how widely it ranges through time, how widely abundance ranges to time, and therefore if it returns to pre-hurricane level after a hurricane. Those are two main questions that we have. In terms of resiliency, how fast abundance returns to pre-hurricane levels. And for that, I will use, we can use different measures, but we will just, I will use two very simple ones, return time, 1 divided by rmax, and double time, which is very much the logarithm of 2 divided by rmax. Rmax, as I was saying, is the maximum intrinsic rate of population growth under ideal conditions, meaning a release from density dependence. Very much the population is at low levels and coming back from that with force, as you will see in the different examples. Bahama Parrot, Hurricane Ike hit it right in the middle. And as you can see, the parrot population was very much stable between 10 and 15,000 animals in the island. And then it declined by 56% on average after Hurricane Ike in 2008. And very much, it took like as you can see clearly there in the graph, like 4 to 6 years. But by year number 4, 2012, basically, the population was back to what it was before the hurricane. And it stayed there, and it seems to be there, stable, if you will. So it shows certain degree of resilience at the same time that it shows stability, and in the very simple sense of what looks like one stable point or domain in which this population is hovering near carrying capacity. Carrying capacity, K, is somewhere between 10,000 and 28,000 birds. So you can see our max, the median is 0.25. It's very high for a parrot population. They start reproducing quite fast after food is coming back. And then we have our predictions that put the population somewhere stable between 5 and 25. Of course, there's a lot of, as you can see, there's a lot of uncertainty as we make projections, you know, further and further in time. And this is due mostly to process variance, which we have accounted for, but there you go. When you account for it, you know, that's the uncertainty you have. In red, you see the model, and in blue, you see the estimates, just to make sure you understand. And the parrot population at this level has less than 1% probability of extinction in the next 10 years. Elfin-Woods warbler. We have the warbler in Yunque affected by Hurricane Hugo, Georges, and then Irma and Maria. You can see how extensive that damage was. And now I used the data collected by Wayne Aaron since 1989, and then Other researchers collected data later in the later years. Basically, the data collection was started after Hurricane Hugo. So basically, we don't know, but looks like the population declined very severely. At any rate, we have now evidence that that decline after George was something like 82%, and after Maria, basically something like 85%. So right now in 2018, our last estimate, accounting for both component of detection probability and using passive and active counts in this case, basically put that at 17%. So local extirpation is quite high right now, as you can see from the predictions in red as we move 10 years into the future. Maximum rate of increase, so warbler, they reproduce fast. So that's, the median is 0.62. So they're capable of really coming back with force and very rapidly. But at the same time, as you can see, they can fluctuate very widely through time, making them, if you will, unstable at certain periods and stable at others. So basically, instead of a simple point of equilibrium or domain like you saw for the parrot, here we might be talking about several points of stability and instability through this time series after we correct for detection probability and we account for process and observation variance. In terms of the plain pigeon, story is very much a little bit different, but looks more like the elfin-woods warbler than the parrot, of course. After we started with in 1986, so basically we have a full analysis after Hugo, George, and after Maria and Irma. And as you can see, very much the same story is repeated. 64% decline after Hugo, 64% decline after George. And then it kind of recovered a little bit up to 2005, 2004, and it started declining again. Very much at the beginning of the 2000s, started declining again. The reason for that is more complex. I don't have time for that, but it's probably related to habitat deterioration and other issues, including illegal hunting and things like that. At any rate, after Maria, we had a huge decline in the population. And now the estimates are putting that bird at 600 birds or so in the island with a 25% probability of extinction. I will go very fast now here just to show the numbers and in comparison the different rmax for the different populations. And I very much will leave it in terms of three conclusions. The parrot is stable and resilient, return back to per-hurricane level in 4 years. But the elfin-woods warbler and the plain pigeon both are unstable and showing wide fluctuations. And they should be considered endangered and critically endangered. Thank you very much.
Thanks for your presentation, Dr. Rivera. Thanks all the speakers, Dr. Joe Wonderly, Jess Zimmerman, Maria Uriarte, Robert Wade, John Faber, and Dr. Frank Rivera-Milan. We thank all attendees in this symposium, and we want to make sure everybody knows that this symposium continues tomorrow in a